Welcome everybody to the webinar of Essential MySQL and PostgreSQL Monitoring, which I put less is more, uh, trying to condensate the idea of having um, a new approach of monitoring that involves what it matters in terms of database performance. So yeah, let's start with it. Um, so yeah, I'm Daniel Guzman Burgos. I have been working with databases for over 15 years, mostly open source relational databases like MySQL and Postgres. I have some um, experience on um, popular NoSQL databases, Mongo, DocumentDB, stuff like that, but primarily working with MySQL and Postgres. I have worked on at Percona, at Rappi, ScratchPay, that the logo it's not showing properly. It's my current employee. Um, ScratchPage, and I have a blog that I call Rendiment that I just wrote. I write technical stuff sometimes when I want to uh, put something out there and just make sure that the community has yet another opinion. So yeah, all right. So let's deep directly on the databases. So uh, what's the purpose of a database? Uh, or why do they do exist? Uh, this question is kind of philosophical. um, it has many different approaches to answers, but I have come in peace to this answer, which is execute queries as fast as possible, as many as possible, right? So that's like the first answer that I provide, and is uh, and it's an answer that will help me on this case. But it's important to clarify that there's actually more tasks that a database has have to do, right? So this is from a preview presentation that I delivered on Percona Live back in 23 in Denver. That I was talking about anomaly detection, and one of the things that I was explaining was like the whole um, activities that a database has to perform, right? It's not only execute queries, but execute queries is the core one, the most important one, as fast as possible, as many as possible. And then you can add things like maintaining data integrity, maintaining data quality. So databases also have a lot of work on the background to make sure that the answer that the query provides is actual the data that was stored in the first place, that has the relationship that as expected, all the stuff. There's also other tasks around relationships and survival. Relationship is interaction with users, so it has to maintain accounts, privilege, access uh, with users. With other databases, there's interaction via replication or FDWs, foreign data wrappers on Postgres with charts. And with developers and operation teams, the interaction goes also through logs and status info. This is important for this particular talk because we will get we want to monitor what's going on. Probably uh, not going to go deep into log and status info, but that's part of the same uh, domain. And then the database needs to survive. It living on a server and has to interact with CPU usage, memory allocation, and disk usage. And they always say it has to survive because it's kind of a struggle, a war, because even if you only have or your main application on a server is the database, the CPU still needs to be shared with the kernel, peripherals, whatever, the same for memory and the same for disk. So it's kind of how I put it as at survive. Um, there's, do you want to go deep on this particular um, information? The talk is available on YouTube. Uh, this presentation will be shared later to everyone that registered. The links will be there if you don't want to go on, just um, do a search on YouTube. So going back to the current talk, for our scope, for this talk, for less is more, the purpose of a database is execute queries as fast as possible, as many as possible, right? So with that being said, let's talk about the journey of this webinar. So it's pretty much three things. It's I put on building the essential, but it's pretty much what are the metrics that I have found are the most important to keep an eye all the time, right? I want to make very clear a distinction that it's not that every other metrics are irrelevant. No, it's that there are metrics that are that says more and are more like a wrapper of everything that it's happening. And there are the metrics that are more useful when you actually go from uh, detection of a problem and go to a debug staging, right? So when there is a problem and you correctly identify that the problem is with a specific query with this table under this load, okay, debug metrics, super important. Let's go do that. But that doesn't mean that you have to look to the debug metrics every single time, or that has to be the first thing that you check when you start your day, or when you start into monitoring. That goes to the second part, which is embracing focus. So if you're looking at the important things, 99% of the time, I guarantee you that you're not gonna miss a big problem, right? So focusing is not a bad thing, right? Discarding noise is not a bad thing. It's not going to put you in a position where things might go down south and you don't know why, or you haven't figured out that after something very catastrophic is happening. And at the end, some actionable insights of how me, my experience, how do I do things yeah, on that respect. So this is a monitoring talk, right? So what's the monitoring paradox that we're trying to talk? What's like the elephant in the room? The elephant in the room is uh, the amount of available metrics and the amount of visible, easy to consume metrics, right? The paradox is that usually monitoring tools or even if you're in cloud and you're using CloudWatch on AWS or the metrics logs and on GCP or whatever you're using, there is way too many information. There's too much information. And there's always a new thing not necessarily a new metric, but a new approach to metrics, or this approach will give you the info faster, or they will give you more info. They will tell you even before things happen. So there's a lot. So this amount of metrics, it kind of goes against the purpose of monitoring, which is, okay, tell me if everything is okay or not okay, right? So that's kind of paradoxical. Um, but then you come with the reality check of more metrics doesn't mean more understanding. And this is something that happens on every stage of the journey of your career, right? It's not that it's not something that only happens when you're junior, or you're entry level, or when or that it's going to disappear when you're going to becoming semi-senior, senior, or whatever. Um, there's always uh, a moment that it's like, okay, I having all this information, but it's a rabbit hole. It's not it's confusing. I'm trying to come to a conclusion, but there are things that are contradicting each other. So uh, that's when you end up in this analysis paralysis, and it's like, I don't know what's going on. I don't know where to start. I have this big problem. I not really sure why, right? So that's part of the paradox. There is this because of too many metrics. When you have notification with your metrics and your alerting system, you you can you will face, or your team will face, the alert fatigue of uh, having alert storms, right? Um, when you have, I don't know, several metrics that will be triggered by uh, the same problem, it will become um, triplicated. You will have, if you don't snooze that, it will come. I will come. I will come. I will come. It will be so much that it becomes meaningless. Sorry. So that's the first thing. False positives, also part of alert fatigue, because it's an alert that you need to address, right? You need to figure out what's going on, if it's really something that's happening. When it's a false positive, you have to fix that, remove that, whatever, do something like that. And the missed opportunities of having this uh, real problem be uh, buried on below all this noise, right? So it's a very high cost. Um, where the teams usually get lost. Two things, which are related. The temptation of this amplitude, right? Like, uh, let's monitor every single metric that we can consume, not only from the database, from the operating system, from whatever. Uh, there's always the temptation, like, and this uh, think of, if the metrics available, well, I have to consume it. If not, why people make it available? And that goes to the illusion of control, which is thinking that uh, or feeling more secure if I have more metrics being monitored, more metrics being part of an alert, more alerts part being of a notification. So not that's not necessarily true, right? Um, what's the philosophy here? And the call of action, it's quality over quantity. There's like I said, there are health metrics and there are debug metrics. Debug metrics are usually the one that are the most of them. Um, Health metrics, it's usually very, very narrow. And if we go back to the purpose of the database, which is execute as much queries as possible, as fast as possible, your health metric is around queries, not around write or read disk latency. That will become later, or around the how the walls are being written, the checkpoint on walls or in other logs in the case of MySQL. It's for execution, everything around query. The power of focus, like once you identify that, focus on that, just focus on that. That will be your daily um, companion, and actual monitoring, like monitoring that uh, that will tell you things that actually requires you to do something, right? So that's the philosophy. So again, queries. The query is the king. The query is the king of the database on performance. What specifically the query execution time? Query execution time is the most critical thing to monitor on a daily basis, right? And what's the measure of the execution time? It's latency. Latency, it's what you have to become an expert. And latency, it's the execution time is like a summatory of latencies at different stages of the query life. So if you know how to identify that and you know how to understand that, everything else it's easier. So let's understand latency real fast. In this case, latency is the time it takes a database query to complete. Okay. This is the most important thing. And you have to understand that when a query start to exist in the perspective of the database, when it's being executed from the app, from your command line, from whatever, starting there until you have the result, right? That's the whole execution time. That's the whole latency. But latency is composed by several stages. Why I'm stressing this? Because this is where the business impact resides. You're having your databases, they're usually performing okay, everything is under the SLOs of the business, all good, until it's not, until there is a query that is taking more time, right? And this is the important thing. There is a queries are taking more time. You don't at this moment you don't care about if it's because high concurrency, if it's because a problem in the query, if it's because it's a new query, if it's because an index was added or removed, or you only care that queries are taking longer, right? I have seen too many teams being super worried about things like load average of the operating system, or the the disk latency is increasing, or the disk queue is increasing. Okay, is that impacting the databases, the queries overall? That's the important thing, right? If there is an impact on query latency, on query execution time, you can have low average going up and And then your queries, the queries that are customer facing or that are important for business are still okay. It doesn't matter, right? Uh, I'm always saying like I don't like to monitor the load average. It's it's usually misleading. It can be up because I don't know, it's sending the it's using more networking on the network card, or there was just something, an impact on a volume that is not the data data volume but something else. So it it doesn't matter until it means that there's an impact on the query execution time, right? So that's why it's important. So back to queries, the query latency, it's pretty much three things: the network time, right? That if it's in the same um, server and you're using SOCKS connection, you know, even you're going through the TCP layer super fast, doesn't matter. And uh, on cloud, this is super important because cloud, even if you're not using database as a service like RDS or Cloud SQL or something like that, but you're using VMs, the actual server and the underlying disk or the volumes, they're connected through a network, right? So if you see, for example, on AWS, the bandwidth between and the network bandwidth between the actual EC2 instance and the EVS, there's a limitation. The limitation it's tied to the instance size. So that's something that will impact the query latency because that will be network time between getting the data through the SAN or the NAS or whatever and going back to the server. So that network time is important. The queue time when is when the when the query needs to wait for a shared resource to be available. What is a shared resource? A mutex, the disk, the network card, a specific row, right? Whatever that is shared, and that inside the database falls into the multi-version concurrency control realm, the query have to wait. It could be the fastest query ever in the world, but if that query is being executed on this very busy, high concurrency, high contention server, well, you have to wait, right? So that will add to the overall execution time. And then is the actual execution time when the query has secured the logs that it needs, that has access to the disk, that uh, everything's on memory, let's say, and it just need to say, okay, I need these rows after the execution plan has been created and is being executed, and the return of the data, right? That result return, the retrieval, think about if you're having these queries that return 1,000 rows or 1,000,000 rows, right? So it's not the same that impact. All right. So from all that conversation, uh, the most important thing to understand is what is intrinsic latency and what is queue latency, right? Because query execution time, it's a mix of both. There's always both, even if one is super low. So intrinsic latency, it's what I was saying, like it's the time that that the query takes to ask the database for the rows and the row being returned. Uh, this is this is where queues doesn't matter. Like you don't have to wait in line for buffer pool to be available. You don't have to wait in line for for a connection to be available, you don't have to wait in line for anything. Logs, everything is available for the query, it goes, and it's just this time. Intrinsic latency, it's when a query, high intrinsic latency, it's a query that needs to be rewritten or has some performance improvements opportunity, right? It's a query against a table without proper index. It's a query against a table that that doesn't have a primary. It's a query that it's probably doing too many joins. A query that it's doing a lot of CPU intensive work in the query, like in the select, you have cases, when, if null, stuff like that. That it doesn't matter if you have the fastest computer in the world, like the query itself needs to be rewritten, the table needs to be rethinking, right? So it's everything around the query itself. That's intrinsic latency. And Q latency, it's okay, Q latency is waiting in line, right? I'm waiting for a connection to be available, for a thread to be available, or a processing in the case of Postgres. I'm waiting for the disk, I'm waiting for the CPU, I'm waiting for something. I'm waiting to get inside the kernel, the kernel or whatever. That it doesn't matter if your query is perfect, it has to wait. And that's more related to hardware resources, concurrency of the server, all the stuff that is shared, right? So it's important to understand this. Okay, now let's talk about MySQL. Everything that I have talked applies to both MySQL and Postgres. I even apply to Oracle, even apply to SQL Server, applies to everything that have data stored and needs to be returned. I don't know, like Excel even, right? So MySQL, what really matters? Okay, the latency, the thread states on MySQL. There are some status that are the thread status, specifically threads running. That's the most important thing. Log wait times to see if queries are being slow because queue latency, because they need a log and the log is not available and has to wait. And of course, the query analysis, but that applies to every database. So the thread states that matter. It's, like I said, threads running. Threads running, it's the measure of actually how many queries are being executed at the same time. There's always a misconception between connections and queries being executed, right? In the case of, I'll talk for Postgres later, but in the case of MySQL, you can have 100 connections, but you can have 99 connections in sleep, right? Or on an open transaction that is not executing queries, right? So having 100 connections open or having 100 connections active as actually connected doesn't mean that there are 100 queries running, right? The one that says to you how many queries are being executed at the same time is threads running, and you can have 100 connections and having just 3 queries running for the moment, right? That's why you see databases that have 10,000 queries per second or 30,000 queries per second, but the connections are like 50 or something like that. And you said, oh, the math, it's not math or whatever. It's because, let's say you are monitoring that value every minute, well, 60 seconds, and each that second can have a lot of queries. And usually on OLTP databases, you're always aiming for the millisecond or 2 millisecond query. So that's a lot of queries that could happen on a second, right? So it's important to not confuse connections with actual threads running, with actual queries being executed. The other important thing is the waiting states. So MySQL, it's known because there are different storage engines, but the most popular is InnoDB. Um, MyISAM was something back in the day. I hope it's not something yet. Um, but you can have my rocks, you can have other stuff. Depending on the storage engine, there's always, you can have a log weight or a table log or a IO weight or a row log or whatever. It's important to understand what type of log are you dealing with uh, for the debug part, right? Usually the most common one is row log weight, which is um, queries that needs to log some rows of a table, but that those rows are being logged by another concurrent transaction, right? And this is why it's important that transaction needs to be small because or faster, because the faster the transaction is, the faster the log will be released, and then the other transaction, the other query that is waiting, it will acquire the log faster. So everything is related. Um, it's important to understand what type of latency you are dealing with, queue or intrinsic. If you have slow queries, but you don't see logs, there's no deadlocks. Resources are available. There's spare cycles on the CPU. Most likely, it's an intrinsic latency. Most likely you need to rewrite your query. You need to figure out your index. You need to figure out if the statistic of your tables are up to date. You need to check out, in the case of Postgres, if your table or tables involved are bloated and have way too much dead tuples. So if there are logs, it's easier. Oh, it's waiting for a queue. So let's figure it out. If there is no logs, there's also can be a queue latency, but more on the side of the hardware. Um, Not enough cores. Um, the disk bandwidth is way too small in the case of cloud. Uh, high read latency. That's very related to the hardware. So, but the first thing is to discard or confirm that it's a lock or not. Right? Uh, so yeah, on MySQL, the log monitoring, it's okay, log wait times. You need to be very careful on that. But it's not something that you need to be looking all the time, like, oh, what are my log waits? Or just focus on query execution time. This this is like the first step of a debugging metric, right? But if your queries are okay, don't stress out on looking at the raw log query times or whatever. But this is the first step to see if there is what type of latency you're dealing with. And of course, for the query analysis, you have the slow query log, the handler statistic. Uh, MySQL has the performance schema for very long time. I think since 5.6. And now it has sys schema. And since MySQL 8, sys schema is part of when you install MySQL, it's available. You don't have to install it. And it's super useful. There's a lot of information there that it's very useful. Not for the regular monitoring, but more like for finding patterns or to doing some postmortem or to figure out uh, if I have some bottlenecks on the disk. It's a problem with the logs, with the IDB log, with the slow log, with a specific table. So it's very useful. It's very useful to to use that. Okay, so let's go to Postgres now. Uh, the same, the most important thing, query execution time. That's something that it's available with Postgres has a lot of views and a lot of tables for monitoring. Can be overwhelmed, but if you start with PGStat activity always, you're golden. pista activity, it's where it's the table that you will query to know what's going on inside the Postgres at that moment that the query was executed, right? How many queries are running, for how long, what was the connection, all the stuff. MySQL I didn't mention, but process list give you that info. Or also if you have sys performance schema enabled and you have the sys schema, there's a sys.processlist view that shows you the same info with less locking. It doesn't have the a full mutex and with more information. So, but Postgres, if you are constantly looking at the pista activity, that's enough. The other key on Postgres, and it's because how the MVCC is written, it's the auto vacuum. Because loading tape auto vacuum is to remove something called dead tuples. Postgres called rows tuples. The way that Postgres is made is that every time there's a data change, an update or a delete or a replace, in MySQL, all that happen in memory, and there's dirty pages, and then it's goes back to the disk in a different way, and whatever that it's have old version of the row. If it was an ID value 1 and you change it to 2, the old value that it has to be available in case you do a rollback. It's not on the table. It's on something else called the redo logs. The undo logs. Sorry. On Postgres, there's something called copy and write. So there are different versions that are tied to the transaction ID of the transaction that modify or do or operates the value on the table, and all those values, once there's no more transaction that meets that, it can be removed, right? So when you do an update under the hood, it's a delete and an insert, but the deleted value is still there and needs to be vacuumed. So that's where the vacuum is for. So the query performance, regular. What's important on pgstat activity? You need to figure out if pgstat activity show you transactions, right? You can have one or more queries inside a transaction, right? You can have a transaction that runs 10 queries and it takes 100 milliseconds. Good. No problem. Commit, the transaction is closed, move on. You can have a transaction that it's open, executes one query and never close, never committed, never roll back. That's a linear transaction, and that is for problems. So it's important to know, identify active queries from open transaction. That's how you do with the idle connection. Idle in transaction, it's an open transaction, right? And also wait events like in MySQL. There's all sorts of mechanisms that the database have to manage shared resources. I'm focusing on seeing a lot of auto vacuum because it can become tricky because auto vacuum it's needed, but also if it's not properly tuned, it can impact the performance. Not doing vacuums impact performance because you will have more dead tuples, so more versions, like the querying it takes longer. But if you wait too much time to execute a vacuum on table, that will be overhead on disk. That will be overhead on the shared resources. So that will impact on the queries. So there's all sorts of recommendations on auto vacuum time, duration, count, all the stuff. But for me, the most important metric here is the dead tuples percentage. I'm always looking at the tuple percentage. I don't care if I have a table that the auto vacuum runs once per day. If that keeps my dead tuple percentage below 5%, that's fine. right? And if the auto vacuum takes very small time, well, better. But what about big tables? On big tables, 5% on big tables is way too. It's a lot of modification, a lot of transactions, or a lot of movement. Um, so in that case, it's also fine if the auto vacuum is not running that often, as long as when you can run it, not like auto vacuum, but like a vacuum that you would call on at night, or where the traffic is not that hard, and then do this huge cleanup. That's also fine. So what it matters is the amount of the tuples more than the auto vacuum um, time, or how many times we executed all the stuff. Okay, sorry. For query performance, the same way that I mentioned that in MySQL you have the performance schema, Postgre comes with an extension that you have to activate, which is pg statements that also collect metrics through time of queries. Super useful for to do query performance. The key metric there, execution time, always execution time. That's useful for query performance. Also, it's important to know the log management of Postgres, the log types, what are the names. MySQL have specific logs like logs gap that it depends on the isolation level. Postgres have like way more logs, so it's important to understand that. But usually the logs um, that have a bigger negative impact are the ones that are exclusive, right? For to write or stuff like that, because those are logs that pauses not only writes but also reads. So that is important. And the deadlock, it's a classic one that you need to check. All right, so let's bring all together. Again, latency, thread state, load contention. I talk of some unique things on MySQL and Postgres, but at the end, it's again query being executed, right? So it's important to have a single page of everything, right? When we were talking about the metrics paradox, we're talking about the availability of metrics, that it's way too many and you have to navigate, right? And you have to, it's not easy depending on the tool, depending if you're using a third-party tool like Datadog or SolarWinds or Splunk, or one of the open sources like PMN, like Signals, like CoreRoot. It's important that you figure it out how to put everything on a single page, right? This is a dashboard that when I was at Percon, I made for overview, right? And it's very useful for overview over time of what's going on with my database. Why is this? Why I'm saying this is important? Because this gives you context, right? If you have a database that the execution time of the query is it's between 40 and 50 milliseconds, then you know that something that is 100 milliseconds, uh, even if it's not super slow, it's an anomaly. It's a outlier, right? So that this gives you this kind of context, right? There's a blog that can be written about that. This is a more specific protect. This is for Postgres. Again, what's the difference? That having auto vacuum information on my SQL dashboard, it's irrelevant, it's useless, right? So these are the common things like the queries per second, amount of connection, number of logs, type of logs per number of stuff like that, and vacuum. Also good, this is Grafana, so it's easy to implement, whatever. I'm pretty sure that other third parties have ways to customize dashboard. It's super easy. I'm just giving this example, but that doesn't mean that these are the only ones that can be done like that. So what's the problem with that is that, and this is a problem not only for PMM, it's a problem with everything that has an agent, everything that has aggregation, everything that has some sort of data cooking under the hood, is that info, it's close to real time, but it's not real time. It's never real time info. There's always a lag. And in my experience, I have seen lags that span from minutes, like, okay, the data is 1 minute old. So this is what was happening a minute ago. Okay, cool. But I have seen monitoring tools that had so many instances that needs to monitor that the aggregation takes an hour, right? So it's too late, right? So for real-time information, nothing beats the terminal. I'm very I'm a guy that likes the keyboard, the terminal, the MySQL client, the PSQL client, all this stuff, because that can be very, very close to real time. That's why I put real time-ish info. You can just run queries like this, which is a query against PGStat activity that I mentioned before, on a loop every second, right? Ordered by execution time, and you can see what's going on. The important thing with these queries and these loops is that you don't have to see patterns, right? The information, if you run this loop every second, it will be super hard to see the data because it will disappear, it will change. That's a good thing, right? Because it's new queries that are coming, new queries. When you start to see a pattern, that's a problem because that's a query that is taking more than a second, right? It's taking more time, more time. So when you have this on a terminal, on another monitor running on a loop, and everything is different, it's good. For my SQL, it's the process list, right? I provide this query with some like already some conditions. Like I don't want to see. Remember when I was talking connection is not queries. You can have very old connections sleeping, not closed, but if you run this query without filtering out that will be always the top one, right? Because the connection that it's open. So, or it could be noise. Here, also, I'm not taking care of in account the ones that sleep, the ones that are related with replication, the ones that on connect, and myself, the connection ID. So if you put this on a loop, it's fine. I also have some Python with pandas that runs those query and then, but on different servers at the same time, and then aggregate everything using pandas and just showing the top 10 or top 20 of the queries being executed on all my database fleet um, on near real time. So that's something that you can do if you're like trying to go to the next step. So real quick, because we're running out of time. This is a very high level mention of alerts. Again, less is more. The critical alert, the warning alert, the informative alerts. It's up to you to decide what do you want to be wake up at 3 a.m. If it's something that you are the person to fix it, you have the knowledge to fix it, and it requires to be fixed immediately, right? the most important piece of information of advice that I can provide to you is to use dynamic thresholds. Dynamic thresholds are thresholds that take care context, right? On the old days of Nagios, or right now with Prometheus and Alert Manager, static threshold is like, okay, CPU is beyond 70%, send me an alert. That's a static threshold. But what about when 75%, 80% of the CPU's usage is actually expected, and okay, you will have alert fatigue. You will get those alerting all the time, and you have to snooze it, silence, stuff like that. With dynamic threshold, you can have context, like details on that blog post. I want to leave some time on the for QA, but pretty much is if a week ago or an hour ago or whatever time relevant is ago, it was also 70% or 75%, then probably it's okay, right, to be 70%. So that's dynamic results. And the most important thing is it's everything is a culture change, right? So it's important to communicate that to your team to say, okay, we are not going to monitor load average, or we are going to monitor load average because X, Y, and Z. Explain not only that you're gonna do it, but also why. So yeah, the key takeaways is prioritize the essential, which in this case is execution time of queries. That's the most important thing. Simplify dashboard. Put everything on a single page. You don't have to go clicking and going to different pages or whatever. Have a good alert strategy that will make you more effective in your work and reduce time. You can be on problems even before it's a bigger problem. So it's worth the change. And okay, that's pretty much it. If you want to contact me, I have this email to my blog, or I'm gonna leave also my GitHub repo. And yeah, if you want to continue conversation, I'm very open to. It's my favorite topic, so it's not a problem if you want me to chat with all of you. Thank you. Thank you very much.
Thank you, Daniel, for your webinar presentation. We are open for Q&A session, and please, guys, ask your questions. We are here for 10 minutes about, so we can. Oh, we have one raised hand. Let's give a allow to talk. Where is it? Where is it? Can you raise again? I will give you a word. I lost your arm. There was also Daniel who wants to speak, and I can allow you. Where are you? Okay. But I can't. I think here. Yeah, I think you want to. It was you. Yeah. Hello. Oh, it was by mistake. I don't know. Raise the hand. Hello, hello. You're open for a question. For some reason, talking is permitted. So you can ask a question and I will read it in a Q&A section or in a chat. I don't know why talking is permitted. I have to try to unmute you, but I couldn't. Okay. So no open questions yet. Guys, you can write a question. Oh, yeah, I see the question. What is your recommendation about using Postgres transactions? Is it always recommended, or there are any suggestions for when to not use them? You can answer like.
Okay. So I don't know if you're talking like using Postgres in general for transactions, or if using explicit transactions or not. So there's one thing that this is also true for MySQL, that every query is a transaction, even if you don't start an explicit transaction, right? There's something called auto commit, that it's something that it's enabled by default and instructs the database to treat every query as a transaction. So even if you just query sending a select and that's it, and that's inside a transaction. Now, when using explicit transactions, the idea of explicit transactions is to have some sort of logical group and ordering of queries that are related to them, right? That's one thing. The other thing is that depending on the isolation level of the databases, there's modifications that are visible inside a transaction that are not visible inside the transaction, right? For example, modify a table and until the commit it's executed, every other transaction might see the old version. So that will depend on that. From a performance perspective, the idea is always to have the smallest transaction as possible. And smallest, I mean, not in the amount of queries, but the transaction execution time overall. Like I said before, you can have a transaction with 10 queries that overall take 100 milliseconds. That's acceptable. If you can have a transaction with 2 queries that each query takes 5 seconds, that's a bigger problem. So yeah, that applies not only for Postgres, that's for every other database. The smaller the transaction, the better. So I hope it is that answering your question.
Hope so. Let's wait for 1-2 minutes. Oh, okay. Another question. The question was because for certain scenarios, there are warning messages in logs saying there is already a transaction in progress. Then if there is no commit or rollback, it becomes ADL, and when ADDL is sent, there could be aggressive logs.
Okay, that's tricky because I'm guessing that you're sending DDLs on visit tables that requires the DDL requires the whole log of the table, right? Depending on the DDL, if you're using concurrent in Postgres specifically, you can have like kind of online DDLs. When you're mixing DDLs, the DDL will always needs to wait for the table lock that to be acquired, and that means that it needs to wait for other queries or other transaction to finish. So this is tricky because you're kind of mixing DDLs that are not part of transaction. In fact, if you have a transaction and you have there are some queries that has like force the commit of the transaction if it's happening, like for example an altered. In those cases, the transaction will be auto committed. But what you're describing, it's more of it's not a best practice approach, like trying to go with those DDLs in when there's a lot of transaction, or not doing it with an online DDL approach. So that's more let's say that's more a DBA work in figuring out how to apply that, if it needs to apply it immediately, or if it can be done on a replica and then promote the replica. You can use like I say a concurrent DDL, so Postgres take care of that online. With MySQL, there's online DDLs, and there are tools that PTLS cannot change or those. There are tools to do online change on Postgres also that are not that popular, but they're available too. So if you want to execute a DDL and avoid having those issues, my recommendation is to go with an online DDL approach. So for the question of Python and pandas, yeah, actually, the whole usage of pandas is to have a single aggregation of every record set of every server, and then when everything is aggregated, I just do an order by the specific column of the data frame, and then show the overall result. So let's say I have 10 databases, 5 MySQL, 5 Postgres. I execute the queries that I show against pgstat activity and against process list. Put everything what is common, like execution time, the query itself, user, whatever you want to put, append it on the data frame, and when I have all that, order by the global execution time, and then show the top 10. That's pretty much what I use the pandas for. I might put that on my repo in the future of the Python code. The front end part, I'm using a library called Streamlit. I don't know if you guys are familiar with it, to show that, but it's easier it's specific for pandas and NumPy to show on a web page, the graphical table and all that stuff. I'm gonna put that on my repo, probably gonna write a blog, and probably put it on LinkedIn when it's available. So yeah. So there could be an application code issue where transaction get notified when the deal like altered table, you supposed to something. Yeah. So the key here is that you mentioned transactions get orphaned. That's a problem, like lingering transactions that are not explicitly commit or rollback. That's the key there, because the transaction will live until the connection, until one timeout hits, the connection timeout, the log timeout, the server timeout. So the approach here is to figure out why the transactions are orphaned, why they are not being committed or rollbacked. And because Postgres and MySQL are ACID compliant, you cannot commit or roll back a transaction from a different transaction, right? That will be against the rules. So there's the only way to deal that if you're not the owner of the transaction, like the owner in the app or you're executing, it's to kill the connection. So yeah, that might be a problem. Okay, I don't see more.
Yep. Thank you for your answers for the questions and for interesting Q&A session, and also for your webinar session. We really enjoy it, and we'll see you soon as well. Please share your presentation, and we will cut off the webinar session and send it to our attendees, and they will have a copy on their emails as well. Thank you, and have a nice day, everybody. Bye-bye.
Thank you. Bye.
Yeah, thank you.